So checking for other configurations, we should go to the all active configuration, then run again the device duty check. We can notice that another problem has occurred. Under normal condition, the rating of the breakers we set is already okay. There will be no error. But once we change the configuration to all active, and we can notice that new errors has come up for all active configuration. So we should come up with a new solution for this. So we can notice that new errors has come up under the all active configuration. So to solve this, we should just repeat the process that we did for the normal configuration. So first, checking what is the error, we can see that the low voltage P11 has a interrupting condition as its operating is 250.59 but its rating is only 200 kiloamps. So its percent operating is too high, which is above 100%, and it is 125.3. So solving for the new rating of this breaker, um, uh, remember that the solution we did for the earlier low voltage circuit breaker is just picking what's in the drop down ratings, which is maximum of 200. And notice that in the alert view, we need 250.591 for its operating. So the value that we needed is higher than 200 kiloamps. So we need to solve for it. So the operating kiloamp goes beyond the interrupting kiloamp. So the manual computation is needed. To solve the interrupting issues of low voltage circuit breaker, the solution is as follows. So again, we should set the rated interrupting to operating. So equals to operating. So the operating that we saw in the alert view earlier is 250.591. So we should have this as our rated interrupting capability. So to solve for the new interrupting kiloamps, we will multiply the rated interrupting capability and the maximum kilovolts over the kilovolts rating. So 250.591 kiloamps multiplied by 0.635 kilovolts over 0.48 kilovolts will be now equal to 331.51. And inputting this to the error, 331.51. So click OK to save the data. Then again, run the device duty to check if there is other errors. So we can now see that circuit breaker 11 is not under marginal or critical condition. To solve for the problems of the other low voltage breaker, just repeat the process. So running again the device duty to check if there is any error for the low voltage circuit breaker. And we can see that it is all now solved. So back to the high voltage breakers for its marginal values. Its condition is the CNL RMS and CNL pink and the interrupting. So we should also manually solve this. So the manual computation that I come up with has the values of 45.7 for the rated interrupting, then 52.29 for the max interrupting, 83.7 for the CNNL RMS, and 141.2 for CNL peak. So the computation for that is I use the rated interrupting for the from the operating again, just like what I did for the previous computations, and same values for the maximum interrupting, same formula for the CNL RMS and the CNL peak. So now repeat the process and input all the values needed for the other breakers. So again, run the device duty to see if there is any other error. And we can say that the short circuit analysis and the device duty check is now all clear for all active configuration. So checking for the other configuration, go to grid down, set this in out of service, then open and up, make the generator in service, then click the device duty and check for the errors. So we can see that there are no errors under the grid down configuration. For the T1 configuration, run duty, there are also no problem. For the T2 down configuration, we also can't see any error for critical and marginal. For T3 down configuration, it's also clear, there are no error. And for the last configuration, the T4 down, and our system for T4 down is also no errors for the short circuit analysis. That's all. Thank you.